Hello good people, I hope you are doing great and having good health by the grace of Almighty. In this video, I am going to explain about the general preparation of alkene. Previously, I have uploaded basic videos on tutorials on alkane naming, alkene and alkynes naming, preparation of alkane, and following the sequences, this video is about alkene preparations. So I am requesting you all to just think very seriously about the steps of every single process of alkene preparations. In this video, I am going to explain 4 different steps or 4 different processes by which we can produce alkene. Simply, I hope you know that the general formula of alkene is CnH2n. And of course, the previous video I have uploaded that the naming process of alkene based on the UPEC system in 1993. So I hope you know about ethene, propene, butene, pentene, hexene. So naming of alkene is the previous video, so I hope you know it. If you know the name of alkene in a good way, then now is the time to focus on the preparation process of alkene. So number one is catalytic dehydration. This is the word, that dehydration of alcohol. Catalytic dehydration of alcohol. So simply we can remember one thing, that if we can remove water from alcohol, then corresponding alkene will be produced. Simply you can remember one thing, that if you remove water from alcohol, then you will find alkene. And those elements or those compounds will perform this. They will be called as dehydrating agent, because dehydration means loss of water. So the losing water process from alcohol, and then it will be produced corresponding alkene, as because corresponding the number of carbon is important. So catalytic dehydration means with the presence of catalyst, this dehydration will be going on. Now you think, simply suppose this is CH2OH. Definitely you know that OH is the functional group of alcohol. If this alcohol is being heated with the presence of aluminium oxide, mind it, if this is 350 to 400 degrees Celsius, then alkene will be produced. So you are heating steam alcohol with the presence of alumina, the fragments of alumina with the heater of 350 to 400 degrees Celsius, then what will happen? CH double bond CH2. So one hydrogen and OH is removed and it will produce water. So simply, if you see that CH3, CH2, CH2OH, that is 3 carbon alcohol. So the name is propanol, and then if you just heat it with the presence of aluminium oxide, Al2O3, you are heating with the presence of aluminium oxide 350 to 400 degrees Celsius, then this propanol will produce propene. So corresponding alkene, the number of carbon is very important. So that would be CH3 bond CH double bond CH2. So this is propene, and water will be removed. So as you see that water is removing from alcohol, and that is producing corresponding alkene, and that is why this is called catalytic dehydration. Catalytic dehydration. And this removal of water means dehydration. And this aluminium oxide or alumina is known as dehydrating agent. Similarly, if this is CH2, CH3, CH2OH, this is alcohol, and you are what? heating aluminium oxide with the presence of aluminum oxide 350 to 400 degrees Celsius. Then as it is alcohol, this is ethanol, so it will produce CH2 double bond CH2 and water will be removed. Simple, okay? In another way, there are other processes like sulfuric acid is also performing as dehydrating agent. In case of ethanol, CH3 CH2OH, if you are mixing sulfuric acid in a way that 2 molar volume of sulfuric acid and 1 molar volume of ethanol is mixed and partially the temperature is 100 degrees Celsius firstly, then what will happen? This hydroxyl and this hydrogen will mix up and water will be removed. Then what will happen? CH3 CH2 HSO4 will be produced and 1 molecule of water will be removed. And then in the second state, this ethyl bisulfate or CH3 CH2 HSO4 will be heated at 160 degrees Celsius. 160 degrees Celsius. Then it will produce ethene CH2 double bond CH2 and sulfuric acid will be same as before. So what is the function of sulfuric acid here? Sulfuric acid is just removing water, from alcohol, and that is why ethene is producing. So first process of alkene preparation is catalytic dehydration of what? Alcohol. So from alcohol we can produce alkene. This would be a very important thing when we will actually transform from alkane to alcohol, alcohol to fatty acid. These things is coming on. So before going to deep into that part or that level, I am requesting you all, please just remember these things. It's all about depending on your practice. The more you practice, the more you can remember. The same thing is also applicable for me. So this is the second way, the catalytic dehydration, this is the first way and this is the second way. So we can have both, aluminium oxide can perform as a dehydrating agent from alcohol to alkene. In case of sulfuric acid, ethanol can be ethene with the help of sulfuric acid in 2 steps. Number 1, 100 degrees Celsius, it will produce ethyl hydrogen sulfate or ethyl bisulfate, and then this ethyl bisulfate will be ethene and sulfuric acid will be removed. So sulfuric acid is taking water from alcohol, and that is why sulfuric acid is called dehydrating agent. Okay, good. Second steps, I'm just erasing all things. And second step is about from petroleum. Okay, petroleum. What is petroleum? Well, I hope you know what is petroleum. In case of fractional distillation of petroleum, I hope you know about fractional distillation. Fractional distillation of petroleum, kerosene is produced in different steps, and dodecane is one of the part of that compounds, kerosene. So from alkene, from higher alkane, in case of petrochemical industries, if we can heat it with the appropriate catalyst, then corresponding alkene will be produced. So the second step is from higher alkane. This is petroleum. Just remember, this is the second process of alkene preparation. What is this? Think about dodecane, C12H26. This is dodecane. That means in this process, aluminium oxide and chromium oxide will be present, and temperature is 500 degrees Celsius. 500 degrees Celsius. So definitely it's a high level of heat, so huge heat will be produced with the presence of appropriate catalyst. And then what will be production? The production is C10H22, number one, and this is not alkene, this is actually decane, and then this is CH2 double bond CH2, that is alkene is producing, that is ethene. So now you see ethene is the production. So you are getting alkene from alkane, where in the petrochemical industries, and this dodecane is the element of kerosene, which is found from the fractional distillation of petroleum. In other case, C12H26, it's also like aluminium oxide and chromium oxide, similar way, that 500 degrees Celsius, but the production is different, that is C8H16, C4H8, and hydrogen can produce. So from dodecane you are having octene. You see, this is octene and this is butene and hydrogen. So we are getting alkene from the higher alkane, which is the production of fractional distillation of petroleum. So this is another process, the general preparation of alkene. So number one is catalytic dehydration of alcohol, that is dehydration of alcohol will produce alkene, and secondly we can find alkene from the higher alkane with the proper catalyst and the temperature. Okay, now let's move into the third steps. I hope you understand this one. Okay, that is very good. In case of third case, we can find alkene from alkyl halide. So third system is from alkyl halide, or you can say from haloalkane. What is this? From haloalkane we also can find alkene. What is haloalkane? Haloalkane means that is Rx. So Rx means, R means alkyl. So suppose CH3, CH2 bromide. So what is the name of this compound? I hope you know that this is alkane, and as this is halide, bromo, and there are 3 carbon, that is bromopropane. So this is alkyl halide. So if we can produce, from alkyl halide, what is the preparation process? Suppose CH3, CH2, Br. This is propyl bromide, okay? And then sodium hydroxide, alcoholio sodium hydroxide. That is very important. Alcoholio sodium hydroxide. What is alcoholio? That means mixture of caustic soda and alcohol. That will produce what? You see, from this, you see, if you just think about this, CH3, CH, Br, okay, that is hydrogen is everywhere, and with this bromine is here. What will happen? There is carbon, so corresponding this 2 carbon, from this 2 carbon, 1 hydrogen and 1 bromine will be removed. And when hydrogen and bromine will be removed, this hydrogen will produce water and this bromine will produce sodium bromide. And as from 2 carbon, from corresponding 2 carbon, both elements are removing 1 single bond, with this bond will produce, which is pi bond, and that is why it will produce CH3, CH, it was 2, so one hydrogen will be removed, so CH, double bond, CH2, alkene, and then what is happening? This bromine is out. So as this bromine is out, definitely there would be a double bond, and this is the propene. With that, sodium bromide and water will be produced. So that is the reaction that we can find, or we can produce alkene from haloalkane or alkyl halide. Okay, alkyl halide. Similarly, if you see that CH3, CH2, if CH3, if there is bromine, then what will happen? Okay, fine. In this case, this is 1 degree. This is 1 degree alkyl halide. 1 degree alkyl halide. In this case, this is 2 degree alkyl halide. So, in this case, if the bromine is connected with the second carbon, then what will happen? Suppose this is sodium hydroxide, and definitely there should be an alcoholic, and then heat will be there. What will happen? This bromine will be removed, and with that the carbon, the associated carbon from this one hydrogen will be lost. So what will happen? The production is CH3, you see, CH3, okay, bond, CH2, so this should be CH. So one hydrogen will be removed, one bromine will be removed. So double bond, CH bond, CH3. So this CH3 will be same. So bromine added with sodium, hydroxide we added hydrogen. So it will produce sodium bromide and water. Now you see that from alkyl halide we can produce alkene with the presence of sodium hydroxide or potassium hydroxide, but that should be in alcoholic mode. Okay, this is the third step of general preparation of alkene. The third is what? That is from alkyl halide or haloalkane. Okay, I hope you understand. Well, let me release and everything. And the fourth stage is the production of alkene from alkyne. So now we can also produce alkene from alkyne. So we can say that that is from alkyne. So we also can find alkene from alkyne, but that should be corresponding. What? Suppose R, C, triple bond, CH. That is alkyne. Okay? From alkyne, what need to be added? That is hydrogen. What will be added? Hydrogen. Okay? Hydrogen. So hydrogen will be added. But the thing is, what is the catalyst? You should remember one thing. The catalyst is palladium with the presence of barium sulfate, and the temperature is 25 degrees Celsius. In this condition, this hydrogen will add with this, and that will produce R, CH, double bond, CH2. So one hydrogen is added with this carbon, CH2, and with this carbon. So one bond will be removed and one double bond would be there. So if you can produce from CH3 bond C, triple bond, CH, that is propene, and if we add hydrogen with this condition, that is palladium with the presence of barium sulfate in 25 degrees Celsius, then it will produce propene, CH3 bond C, H double bond, CH2. Even if you just make it shorter, CH triple bond CH with the presence of hydrogen, and there should be palladium and barium sulfate and 25 degrees Celsius, CH2 double bond CH2 alkene, that is ethene, will be produced. Okay, so I have explained 4 different process of alkene preparation, that is general preparation of alkene. So I have written this thing. So again, if I want to wrap up the class, I hope that I can explain things clearly to you, and things depends on your practice. If you practice more and more, you can understand. And I'm just assuring you that organic chemistry is such a wonderful thing. It's a lovely part of chemistry. If you can find the essence of organic chemistry, you will feel definitely better. So if I can wrap up, what is the main thing that to remember? That is, in case of what? In case of catalytic dehydration of alcohol, what should be? Alcohol. What should be the process? In case of alcohol, what to be? I mean, aluminium oxide and 350 to 400 degrees Celsius should be there, and then it will produce C double bond C. As means we want to produce alkene. Number 2, from what? Higher alkene. So we produced what? C12H26, that is higher alkene, that is dodecane. So what is the catalytic actions is there? That is aluminium oxide will be here with the presence of chromium oxide, and temperature is 500 degrees Celsius. So also we will find alkene. In third way, what was the same? Is alkyl halide. So when there is alkyl halide, that should be with the presence of sodium hydroxide, but that is alcoholic. Then also we can find alkene. And in other case, number 4, when there is triple bond, that is alkyne, we can mix hydrogen with the presence of palladium and barium sulfate. Temperature is 25 degrees Celsius. We can find what? Carbon-carbon double bond. So that is the 4 process. I have written a shorter way so that you can remember, and you must remember the title. So after watching this tutorial, if you have any problem or something to say, please feel free to write in the comment box. And of course, Facebook is there, Fahad's tutorial Facebook page. You can communicate with me. Please let me know your feedback. I hope you can study well with joy and inside a peaceful manner. It's all about having your mindset. You can take it easily, things will be much more enjoyable. Take care, see you on the next video. Bye.